15 minutes. That's perfect.
Okay. So what do I hit to stop it?
The red button.
The red button that's lit up here? Okay.
Okay, so I want to talk about logarithms, the logarithm rules. We have three main rules that we use to simplify equations. The log of any base of two things multiplied together can be expanded to the log of whatever that base is of the first number plus the log of that base of the second number. So times expands to add. When it's division, it expands to subtraction. And then this is really big for us to solve the equations. When it's raised to a power, the power is a multiplier. Just like all of our exponent rules, a power, like a log, is an exponent. The answer to the log is an exponent. Raised to an exponent, multiplied. So the R wraps around in front of this as a multiplier on that log. So number 83 on your study guide asks you to expand this using these rules. So the first thing you notice is log base b. It doesn't matter what base it is, the logs apply. So log base b is going to be expanded. It says the square root of all of this quantity. So think of this big square root as being a 1/2 power around all of these terms. So that is raised to the 1/2 power, which then can be multiplied around in front by this rule that says powers become multipliers on the log. So that's how I got this 1/2 in front of this expression. All right, then expanding the part that's in here, it's log base b of the 4. There's an understood times between that, so it's plus log base b of the x to the 7th. And then because this is divide, that expands to subtract log base b of z to the 4. So, and again, the 1/2 is times onto all that, because all of this was raised to the 1/2 power. Square root means 1/2 power. Now, also inside of these terms, if there's an exponent on a specific log, that can come down as a multiplier. So the 7 is in front of that, and so is this 4 in front of that log. Then I distribute the 1/2 into my terms. So I get 1/2 of this log base b of 4, 1/2, and there's a 7 there, so 1/2 times 7 is 7/2 log base b of x, and then 1/2 times the 4 that I brought down makes, oops, that makes 2. 2 log base b of the z. And then you can find that answer on your answer key. The only one extra move they make is this 1/2 multiplier can also be taken back up as an exponent. You know, an exponent or multiplier mean the same thing. So 4 to the 1/2 power means square root of 4 or 2. So on your answer key, you see that written as a 2. Then 7/2 and then minus 2. So that was just kind of experimenting around with these rules with some abstract algebra, not really solving a concrete problem to find x value, just using the rules. All right, the next problem, 84. Also applying these rules, says to find log base b of a divided by b, which according to our rules, the log of any base, whether it's an a, a number, or whatever it is, log of any base with two things divided means you'll subtract those two logarithms. So it would be log base b of a, subtract log base b of b. Those numbers are provided in your directions. It says log base b of a is 3.230. Log base b of b given in the directions is 0.387. So we're just supposed to know that this means to subtract those two values. So subtract that on your calculator. Just do it, and that's the answer that you're looking for. Okay, number 85 is using the pH formula. It tells us in the directions that pH is equal to the negative log of this specific concentration, which will be given to you in the problem. Directly given to you in the problem, this concentration is said to be 5.4 times 10 to the negative 11. So we just drop that number that's provided, that concentration is provided, drop it into the formula, and then pH will be the negative log of that. So it's directly just plug that, the way it's stated, into your calculator and verify the answer should be 10.3. So again, practice that on your calculator. Make sure you know how to punch that in. Okay, 86 is another formula problem. It tells us that a Richter scale value can be found by measuring the intensity of an earthquake divided by a reference level intensity that's given. In our problem, and then taking the log of that, sorry. The formula is log of intensity divided by reference intensity. So that's given in the problem, and then it tells us that they've recorded an earthquake that had an intensity that was 31623 more than, or times the reference intensity. Whatever ISOBO is, the reference intensity, we don't know, but whatever it is, it's 31,623 times more powerful than that. Then the formula says divide it by the reference intensity and then take the log of that value. So that's the formula for Richter scale. Notice the isobos, the reference level cancels out whatever it may be, and it's just log of that number. So again, you can directly type that on your calculator. It's assumed to be a base 10 log, just like our pH problem was. It was just log with a base 10. It's not stated. So that can be directly plugged into your calculator. Okay, so like I said, if it's a base 10, it's a direct button pushing thing. It's log 31623 equals, there it is. But if it's not a base 10 or a base E is the LN button, if it's a different base, you'll have to use the change of base rule, which says take the log of 2.6 divided by the log of 5.8. You can also use the LN logarithm. The ratio comes out the same. As long as you use the same log base, when you do this, it's okay. So punch that on your calculator. Things I've seen done on this that cause a mistake on your answer is closing the parenthesis. Your calculator brings up a parenthesis automatically when you hit log. You have to close it and then say divided by log 5.8. Close that. So to check your answer, number 87 this is, you should get answer B, which is 0.5436. Put a 0 in front of that as well. This means, am I too low?
Yeah.
This negative, or this 0.5436 answer means 5.8 raised to that power equals 2.6. That's what a logarithm means. It means find the exponent needed to make this happen. So check it out on your calculator. It's 5.8 raised to the 0.5436 equal to 2.6. And you'll know if you got that right or not. Okay, number 88. F of x equals 5 to the x. We're using a function notation that says find f of log base 5 of 4. F of x notation means this is your input value x. This is a regular function, so plug that in for x. Normally, the function notation means plug this, whatever is beside of f, plug that in for x in the function. The only exception to that is when we do the inverse function, it has a little -1 exponent, then that's the y value. It's backwards on the inverse. But anyway, that just means put that in that x spot. So this will be f of x equals 5 raised to that log base 5 of 4. Now we have a logarithm rule that says if you're raising 5 to the log of that same base 5, all that cancels out and it just equals the 4. The 4 comes down. And that is an also theorem. I didn't write that one down on your list, but that one is listed in your notes. Okay, number 89. Now this is the big thing that we've been able to do with logarithms. It's kind of the peak of why we've been using all these logs. Is so we'll be able to solve equations with unknown exponents. You know, before in algebra there was no way to figure out what that x was without logarithms. And unless you could get like bases. And I know 5 and 10 are related, but they're not like base. Like 10 is not 5 to the second or 5 to the third. So I can't make this a power of 5. It is 5 times 2, but that doesn't count. It has to be a power of 5. So there's no way to make like bases from that. So we need logarithms to do that. So the big thing, the big crescendo of this whole log discussion is this last rule that says if you're trying to solve an equation that has an unknown exponent, if there is a log, if it's a logarithm, log is written in front of that, the exponent will come down on the level as a multiplier and you'll be able to solve it. So what I'm going to do is take the logarithm or log of each side of this equation. So why don't you do the same thing to each side, do whatever you want. So we're allowed to do that. That now makes this exponent a multiplier. There are 2 pieces to it, so keep a parenthesis. Now notice there was no exponent on this, so it's understood to be 1, so we don't really have anything to deal with there. All right, so here's our equation to solve. If you wanted to, you could write the value of log 5 by hitting that on your calculator and see it's just a value. It means 10 to what power is 5, so it has a real-time value. Log base 10 or log 10, you may know, is 1 because this means 10 to what power is 10. So we could just cross that out, call that 1. It's equivalent to 1, and I think I'll do that just to make my calculations easy. Now for log 5, it doesn't come out nicely. It's not an even integer number, so I probably wouldn't want to transfer that out to its decimal value because if it doesn't come out even, it's an irrational number. It doesn't stop, it doesn't repeat, so it's kind of a not nice number. So we prefer to keep it so we don't have round off of it. So I'll probably just use the word log 5 and distribute that. 2, let me come up over here, 2x times log 5. Just distributing 2x log 5 and negative 1 log 5 equals 1. And now I'm trying to solve for x, so I want to get x alone. So this term is my x term. This does not have x in it, so throw it across the line like we do all constants. Gather the constants. And then to solve this, we divide by what's around the x, so I'll divide out by 2. And remember, log 5, it's not a mysterious number. It is a value on your calculator. It's 10 to what power is 5, so it's a decimal value. So it's a constant like any other constant. We divide it out. So those cancel. Do the same thing to both sides, divide by 2 and log 5. And that will be your x value when punched on your calculator. Carefully punched on your calculator. You'll need parentheses around the numerator and not necessarily around the denominator, although it wouldn't hurt to be on the safe side. Sometimes if there's 2 parts to it, you do need a parenthesis. So maybe we should just do that anyway. So you punch all that in directly into your calculator. Then the answer should be, I forgot what number I was doing, number 89. Should be answer B, which is 1.215. And then you can check that out back in the original problem. 5 raised to 2 times 1.215 minus 1 should equal 10, and you can verify. Hit the red button.